Okay, hi, welcome everyone. Here we are going to look at 5.5D, right? We're still on graphs, and in this subtopic, we're going to look at other different kinds of graphs. Okay, but before we go on, right, let's go back to our basic concept of how to read a graph. So the graph will tell us the level of certain quantity, right? Whether you have like how much of a quantity do you have. So for example, it can be time over here, but you have your production levels up and down, something like that. So that's the first way to read the graph. The second way to read the graph is actually to look at the gradient of the graph. So sometimes we have to look at the steepness of the graph to tell us whether something is fast or whether something is slow, whether is the rates high or whether are the rates low. Okay, so with this one over here, let me draw you to two concepts over here. Okay, so the first concept is this one, right? So let's look at the first graph over here. Okay, so let's imagine that we have this y equals to mx plus c. Okay, now there is this special thing about this m, right, and this c over here. Okay, so what does the m represent? M represents the gradient. Okay, and the gradient, right, is actually representing your rate of change to see that whether something changes fast or whether something changes slow. Okay, and the c over here is going to be your y-intercept. And what does the y-intercept tell you? It tells you the initial condition, right? So what happens at the beginning of the situation, so which is over here, this point over here, right, will tell you the initial condition of a certain situation. Okay, so with that, let us look at two more graphs over here. Okay, so we have two graphs over here. So this one, the gradient for this graph is lower, so meaning the rate over here is going to be a bit lower because it is less steep. And the one over there, the gradient is higher, and over here the rate is going to be higher because it's more steep. Okay, similarly the other way around. Okay, let's say if you have a negative gradient, steeper gradient, higher rate, less steep gradient, less rate. It's just that the rate of decrease is going to be higher. Okay, so yeah, so let me just sketch it over here, right? One over here, one over there, right? So let's say if you have two straight line graphs over here, this gradient is going to be a bit, okay, so the absolute value, right, just the number itself, the absolute value, the number itself is going to be lower because it's less steep. Okay, so then because of that, the rate is going to be lower. This one over here is steeper, right? The absolute value of the gradient, meaning just the value of the number itself, is going to be higher, so the rate is going to be higher. Okay, so without further ado, let's take a look at the first kind of weird graph that we're going to see in this subtopic over here. It's going to look, this is called our step function graph, right? So over here, what is a step function graph? It actually looks like a staircase. Okay, staircase over here, and it shows the local postage rates for letters, postcards, and small packages offered by company A. So it is like what we see in our inequality when we want to draw the number line over there. Alright, so this one over here means that it will take this value, right? So this is an included value, right? So this part, it will include this value. Where it is open, this is actually not included, right? Not included this point. Okay, so means when you read this over here, let's say the duration, right, is going to be 5 hours, we are going to read this included value and not at this one that is not included. Okay, so the black color dot means it is inclusive, the white color dot means we exclude the number, okay, for that part, and we read the one with the black dots. Okay, so with this concept over here, with this how to read, let's take a look over here. This is actually a local postage rates for letters, postcards, and small packages offered by company A. And we have, oh sorry, this is actually car park. Sorry, I think I typed the wrong context over here, right? So I think this is parking for car park X. Okay, apologies. So this is going to be the wrong context, right? So this is car park X. Okay. Okay, so interesting. So this is car park X. So car park X has the car park Y has the following charges: free for the first 12 minutes and 2.5 cents per minute thereafter. So insert the graph for car park Y's parking rate. So we need to draw the graph for car park Y. Okay, so over here, right, it's going to be free for the first 12 minutes. First 12 minutes, right, means that how many hours is this? This is going to be 0.2 hours. Okay, so 12 over 60 is 0.2 hours. So free for the first 12 minutes, so meaning from 1 to 0. Okay, so until 0.2 is going to be free like this. Okay, so we have a straight line graph over here at the bottom. Okay, and then we have 2.5 cents per minute thereafter. Okay, so means in the next 1 hour. Okay, so if you have 2.5 cents per minute, so 1 minute, you raise by 2.5 cents in 1 hour, right, which is 60 minutes. So that's easier to draw. So let us multiply this by 60 and we get something like 90 cents. Okay, so the next hour, so after this point over here, the next hour is going to be 1.2 hours. It's going to raise up by 90 cents. Okay, so we need to plot somewhere over here, like this. Okay, 1 hour later, which is 2.2 hours, right, we're going to go up with another 90 cents, so it's going to be 180. So 2.2, we're going to go up to 180 over here. Okay, then another 1 hour, which is 3.2 hours, it's going to go up with another 90 cents, so it's going to be 270, which is somewhere over here, I believe. Right, the next one plus another 1 hour is going to be 4.2 hours. 4.2 hours is going to be 2.7 plus 90 cents, going to be 360. So $360 over here. Okay, sorry, at 4.2. Okay, 360 at 4.2. Next hour, 5.2 is going to give us 360, 450. Right, 450 somewhere halfway there. Okay, nice. Last one, 6.2 hours is going to give us 540. 540 will be somewhere over here. So I can actually draw a graph joining from that part all the way to this one over here. Okay, so let me adjust this a little. Okay, so this one needs some adjusting. Okay, over here needs a little bit adjusting also. Okay, how come weirdly it doesn't pass through this one point? Maybe the graph paper, maybe my graph paper isn't like that correct after all. Interesting. Okay, but anyway, alright, so Ali wants to park, so this is the graph for car park Y. Right, car park Y over here. Okay, alright, so Ali wants to park his car at one of the car parks or 2 hours. From the graph, determine the car park that will offer the cheaper rate. So obviously the car park that's offering the cheaper rate is car park Y, because the car parks are the prices are way below the parking charges for car park X. You see the car park X, the graph is above, car park Y is below, so car park Y has a lower charge. Okay, or if you want, you can actually read 2 hours. At 2 hours, the lower reading is actually car park Y as compared to car park X, where you have to pay $2 plus. Okay, so over here is going to be car park Y. Simple answer. Okay. Okay, so with this on your own, I believe you can try this part over here on the postage rates. Okay. And we're going to move on directly to other graph with rates. Okay, so this one, let's take a look at this example over here where we look at Joyce's heart rate in beats per minute. So she rests at the bench for 10 minutes. So this is her heart rate at the first 10 minutes. And she walks briskly for another 10 minutes. She slows down for 5 minutes before walking briskly for a further 5 minutes. Jog at constant speed for 10 minutes before gradually slowing down. Okay, so the different parts of the graph tells you the different heart rates. Okay, so state her resting heart rate. Resting heart rate means the heart rate where she's really sitting down and resting. So which are we looking at? This one over here. So this is going to be 60, and we follow the unit beats per minute. Okay, now find the rate of increase in her heart rate during the first brisk walk. So what do you mean by rate of increase? Rate meaning we need to look for gradient. Okay, so how do we look for gradient over here? So the gradient is equals to rise over run. So how much rise is this? 60 to 120, or we can make use of y2 minus y1, right, which is the rise, x2 minus x1, so 20 minus 10. Okay, so let's take a look at the units let's take a look at the units above. So 120, so this is actually beats per minute, so this is in minutes as well. Okay, so the rate of increase in heart rate, right, is going to be equals to 6 BPM, beats per minute. Okay, like that. Okay, next find the rate of decrease in heart rate. So we are looking for the rate again, right, as she slows down in the last 20 minutes. So where's the last 20 minutes? Over here, right, over here. So let's take a look at the rate over there, right? So rate, if we want to find rate, means we are looking for the gradient. And how do we look for the gradient? The gradient is equals to y2 minus y1, so 120 minus 140, so 120 minus 140, y2 minus y1, x2 minus x1, so 60 minus 40. Okay, so 60 minus 40. So, and the top over here, the unit is beats per minute, and the bottom is going to be minute. So this is going to be negative 20 over 20, so negative 1, right, beats per minute for every single minute. Alright, so every single minute her heartbeat is going to drop by 1 beat per minute. Okay, so over here, what is the rate of decrease? Because the rate of increase is negative 1, so the rate of decrease is going to be 1 BPM per minute. Alright, so this is the example for the heartbeat rate question. Okay, so with this on your own, you can try the next page over here to show the temperature variation inside the oven. Right, so that's all that I have today. Hope you enjoyed today's lesson on looking at gradients as the rate. Okay, looking at gradients as the rate, looking at C as the initial condition or the beginning condition, and also to analyze some step function graphs over here. Right, so with that, have a good day ahead, and see you in the next time.